Welcome back. This is Mr. Greenstein's Geometry. We're talking about Chapter 7, Section 7, Circles in a Coordinate Plane, and this is Part 2. We're going to talk about the standard equation for a circle. So if two circles have the same radius but different centers, for point 4, y on the circle, what is y? So here we have a circle that's centered at 0, 0, and then we put a point out here that's 4 across and y up. So if I was to draw this, I would have this kind of right triangle going on. So what is this? What are the coordinates? It turns out that the radius is going to be 5. We know that. But when we calculate y is going to be 3. So it's going to be 4, 3 is the location on the circle. Now if I go over to the other circle here, it has a radius of 5, but the center is not on the origin. It's on a place called HK. Now I can draw the same right triangle, and the right triangle is going to go across and then down like this, and then the hypotenuse there, so the right angle is here. We know that the radius is going to be 5. So we have the distance from the center all the way up to this point here, but it's no longer 4, y. So we have to take this and exit out. It's no longer 4, y. What is it? So now we have to take a look at how we're going to have a standard equation for the circle. So a standard equation for a circle. We have this point for the center, HK, and we have a point on the circle, XY. We know that the distance formula from one point to another is going to be this formula. Then we just take that and substitute these points. So we have XY and we have HK, and we just put them in for the X2, Y2, X1, Y1. And the distance from here to there is going to be the radius. So that's all we're doing. We're just substituting in these different numbers here. And then we take that and we square each side. And we get radius squared is equal to x minus h plus y minus k. And this is what we call the standard equation for a circle. Standard equation. Now write the standard equation for the following circles. So if I have a radius of 3, that means that I'm going to make this 3 squared. And then the center of 3, negative 4, that equals the quantity x minus 3, and that quantity squared, plus y minus a negative 4, which is going to be plus 4, and then square that. So then we have our equation for that first radius and for the center. I'm going to leave it to you to come up with the equation for this particular circle with this radius and this center. Now let's sketch the circle. We're shown a couple things. We have this component here, 3, and we have negative 2 here. But really, what we're looking for is some form that has x minus h squared. So x minus h, well, h would have to be negative 3. So the center is going to be at -3. And then we also have the part y minus k squared. And that's going to be 2 for k. So 2 for k, and that's the center of our circle. So if I count over -3, 1, 2, 3, and then +2, I end up with a center here. And then I have the component out here. This is radius squared. Well, then the radius has to be the square root of that, or 6. So I can count out 6 from the center, and I'll count out to the left, 1, 2, 3, 4, 5, 6. To the left, I'll count up 1, 2, 3, 4, 5, 6. I'll count to the right, or to the left, 1, 2, 3, 4, 5, 6. And then down, 1, 2, 3, 4, 5, and 6. And then I'll just sketch my circle like that. So now I have a circle that relates to this equation by identifying the center and the radius. Rewrite the formula into standard form. So this is not in standard form, you can see. So what we're going to do is we're going to move things around. We're first going to take this, and we're -16, so we're going to add 16 to both sides. And when we do that, then we lose the -16 on this side, and we add 16 to the other side. And then I'm going to add 20 to each side. 20 here and 20 there. And the next thing I'm going to do is I'm going to divide out 16 of that 20 and put it in this quantity, and 4 of that 20 and put it into this quantity. And when I add the 16 and 20, I get 36 on this side. Then I just factor this, and I factor this, and I get x minus 4 squared and y plus 2 squared. And this turns into 16 or 6 squared. Once I have that, then I can figure out my center. My center is going to be 4, -2, and my radius is going to be 6. So if I plot out 4, -2, that's right around here. And then I count out 6 in each direction. 1, 2, 3, 4, 5, 6 in this direction. 1, 2, 3, 4, 5, 6 in this direction. To the left, 1, 2, 3, 4, 5, 6. And then down, 1, 2, 3, 4, 5, 6. So now I have this sketch of a circle. And then that circle represents this equation that we started out with, that just as we converted it into something that was the standard form so we can see what it has to look like. Now we prove or disprove that the point, the square root of 2, square root of 2, lies on the circle centered at the origin and containing the point 2.0. So we can prove that. If it's centered at the origin, then we know that it's going to be x minus 0 squared plus y minus 0 squared equals radius squared. And if we have something that's centered at 0, and it has a point 2.0 or 2, 0, then we know that the radius has to equal 2. So if the radius equals 2, then we fill this in, and this becomes 2 squared. prove or disprove that the point square root 2 square root of 2, so we plug in square root of 2 here, and that's squared, plus the square root of 2, and that's squared. And does that equal 2 squared? Well, this turns out to be 2. This turns out to be 2. That equals 4. And 4 is definitely equal to 2 squared. Therefore, we have proven that square root 2 square root of 2 lies on the circle centered at the origin and containing the point 2, 0. We will discuss more of this in class the next day.